Hey, welcome to 13.3, Part 2. So in this lesson, you're going to learn how to graph a reference angle, and you're going to learn how to use a reference angle to find a trig value of any angle given with the unit circle also. So it might be handy if you have your unit circle out right now. So when I make an angle, the reference angle is considered the positive acute angle that is formed by the terminal side and the x-axis. And by the way, we show reference angle as theta prime is a reference angle. So let me show you what I mean by this. I drew the 4 quadrants here based off of what your picture looks like when it lands in each of the 4 quadrants. We're going to start with quadrant 1. I'm going to make a little sketch right now. I've got my angle. I put it in this quadrant because I mean the terminal side or the ending side ends in quadrant 1. So the reference angle is right here. It's between the terminal side and the x-axis. Here's the x-axis, here's the terminal side. So that is my reference angle, theta prime. Let's look at what it would look like in quadrant 2. If it lands in quadrant 2, it would be over here. And again, it's the terminal side and the x-axis. So x-axis down here, so the reference angle would be right there. We'll draw a picture for each one of the quadrants. In quadrant 3, it lands down here. And again, terminal side and the x-axis. And last but not least, in quadrant 4, here's my picture. Again, it ends in quadrant 4. And then my reference angle is with the terminal side and the x-axis. Sometimes students forget which axis to go to, so here's a kind of like a little trick I show my students. Always make a bow tie with your reference angles. So if I put all 4 of these pictures together, it makes a bow tie. So always make a bow tie with your reference angles. Do not make the hourglass. That would be the hourglass. No, wrong. Make a bow tie with your reference angles. Now, how do I find a reference angle is the next question. It's best if I do an example or two and then we'll come back and try to make a formula for it. But here's what's going to happen. Look at example 1. To find a reference angle, first you're going to graph the original angle. Going back to our skills we learned in section 13.2. Right now I want to do negative 150, and I'm kind of jumping ahead of myself. First step is I want to label appropriately based off of what type of angle I have. In this case I have a negative angle, so I'm going to label in the negative direction. And then in my mind I'm thinking, okay, negative 150, that's in between negative 90 and negative 180, so that's going to be somewhere over here. Now my reference angle again makes a bow tie with the x-axis, so here is where my reference angle is. I am trying to find what distance it is from here to the x-axis. What is that distance is the question. And I end up getting 30 degrees because it's 30 degrees to go from 150 to 180. And by the way, a reference angle is always positive. It already said that up here, right here, but you might want to put a star by it. A reference angle is always a positive angle. Let's do one more, and then we'll see if we can kind of come up with a formula for this. This time I've got 300 degrees. It's a positive angle, so when I go through and draw my angle, I'm going to label in the positive direction. Here is my angle, approximately 300 degrees. And again, I have to ask myself, what's the distance to the x-axis? How many degrees away from the x-axis is this spot? And if I go from 300 to 360, that is 60 degrees away from the x-axis. So I want to pause right now because students always ask me, well, is there some formula I can do to find the reference angle? There isn't really. I could create a formula that works in some situations, but it's best if you just use your logic every time. Like here I was able to see that that's 30 degrees away from the 180, and here I was able to see it's 60 degrees away. Now, why did I say 60 instead of saying 300? Well, a reference angle is always also acute. So that means it's between 0 and 90. So I knew that it was not going to be 300, it's going to be between 0 and 90, so I used 60. Now, if you're a real formula person, in general, but only if it's an angle and it's positive, usually in this quadrant you can do 180 subtract your angle and get the answer, and usually in this quadrant you can do their theta subtract 180, and usually in this quadrant you can do 360 minus your angle. Now again, I don't really like students to use those formulas because every single time it's going to be different, and they don't really work if it's a negative angle. So I would recommend that you just use logic every time. It does get harder as soon as we get to radians, so that's what we're going to look at next with example C and D. For example C, I want to graph 7 pi over 4. Now, first thing I am thinking in my mind is that I am in radians. So right away, I am going to write down the regular radian measurements, which usually are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The problem with that is I have 7 pi over 4, and it's difficult for me to figure out where my angle is going to land because these are all pi over 2. So what I want to do is make a common denominator, and luckily 4 I can easily get as a common denominator with a 2 on bottom because I'm going to multiply this one by 2 over 2. So pi over 2 is the same thing as 2 pi over 4. Pi is the same thing as 4 pi over 4. And again, I'm finding a common denominator for all of my labels on my graph. 3 pi over 2 is the same thing as 6 pi over 4. And 2 pi is the same thing as 8 pi over 4. Now you might want to pause and rewatch that if that didn't really make sense, but again, I just had to find a common denominator so it matched with my 7 pi over 4 so I could more easily graph it. Now that I have that, I can kind of see, okay, 7 pi over 4, that's going to be in between 6 pi over 4 and 8 pi over 4, so it's going to end here in quadrant 4, right here. That is my 7 pi over 4. Here's my reference angle. And then here is where me using logic comes in. I want to go from 7 pi over 4 to 8 pi over 4. What is the distance from 7 pi over 4 to 8 pi over 4? Well, the distance is 1 pi over 4, or just pi over 4. Let's do another one that's in radians. And I want to tell you that whenever you get an angle that is greater than 360, it is to our advantage to just subtract off 360 or subtract off or add 2 pi to make it not greater than 1 full revolution. It's just easier to graph. So I see a 4 on bottom. In my mind, I'm kind of thinking about the previous problem we just did, and I'm thinking that, remember we said 2 pi is the same thing as 8 pi over 4. 13 is clearly bigger than 8. So I know that I could get rid of a revolution right now. And remember, to get rid of a revolution, I add or subtract 2 pi. That's like me finding a coterminal angle from section 13.2. Negative 13 pi plus 8 pi is negative 5 pi over 4. That's just going to be easier to graph than negative 13 pi over 4. I will get the same answer. So I'm going to graph negative 5 pi over 4. Now, for this one, I am going in the negative direction, so I am going to right away graph my negative radians. So 0 down to negative pi over 2, up to negative pi, and then up here to negative 3 pi over 2. But once again, it is in fourths. So I want to make a common denominator. So pi over 2, and this is actually the same thing I did up here, just it's reflected down when it's negative. So that's going to be negative 2 pi over 4. This one here, negative pi, that's going to be the same thing as negative 4 pi over 4. This up here is going to be the same thing as negative 6 pi over 4, and I can stop there because negative 5 pi over 4 is going to be in between 4 and 6. So there is my reference angle, and that is at negative 5 pi over 4. And now I need to ask myself, remember, you're always finding the distance back to the x-axis. So what's the distance from negative 5 pi over 4 to 4 pi over 4? And that is, again, a distance of pi over 4, 1 pi over 4. Remember, reference angle is always positive. Please go back and rewatch those if you need to. I'm going to keep going because this is kind of a tough section. If you feel like you can do it on your own, you can pause and try it and then fast forward later. But I would recommend to keep listening for most of you since this is so difficult. All right, let's look at E. I've got 258 for my angle. Now, I am in degrees and I am positive. So I'm immediately going to start by labeling the normal 0, 90, 180, 270, and I can stop because 258 is in between 180 and 270. So here's my reference angle right here. And I need to find the distance from 258 to 180. And here is where this one situation I would actually use the formula, a quote formula, because in order to figure out what that distance is, I'm going to do 258 subtract 180, and it ends up being 78 degrees. We're going to do another radian one next, so I'm going to do 4 pi over 5. First of all, it's positive, so I'm going to start labeling my radians in the positive direction. So pi over 2, pi, 3 pi over 2. And then, unfortunately, I have a denominator that is a 5, an odd number. So that's not going to be quite as easy to make my common denominator, but 5 times 2 is 10. So let's make our common denominator 10. So for my actual original angle I was given, it actually is the same thing as 8 pi over 10. Let me go through and now find a common denominator for all these other ones. So for these other ones, or at least, well, I should say just this first one, in order to make it over 10, I need to multiply by 5 over 5. So that would be 5 pi over 10 for that first label. This one, pi, is the same thing as 10 pi over 10, and essentially it's like pi over 1, so I multiplied by 10 over 10. For 3 pi over 2, I again have to multiply by 5 in order to make it a 10 on bottom. And 3 times 5 is 15. And actually, oops, I could have stopped a long time ago because I was looking for 8 pi over 10. And that is going to be right here in between 5 pi over 10 and 10 pi over 10. So here's my reference angle. And in my mind, I'm thinking, what's the distance from 8 pi over 10 to 10 pi over 10? 8 pi over 10 to 10 pi over 10. That's 2 pi over 10. Which reduces down to pi over 5. So that is my reference angle this time. After you feel like you understand that, go ahead and flip to the back. You may have noticed on your unit circle that there are a lot of points that have this as their xy, only sometimes they're positive, sometimes they're negative. There's a lot of points that have this as their xy, only sometimes they're positive, sometimes they're negative. The thing is, by using a reference angle, I can graph any angle on the unit circle, and I can just use quadrant 1 of the unit circle to figure out what the value of it is. This is difficult, so I'm going to do some examples here, and then we are going to work on this a lot during class. Here's what we're going to do. First, find the reference angle. And then we're going to evaluate the trig function for that reference angle. And then based off the quadrant, we're going to determine if it is positive or negative. Look back to your unit circle to think about where sine, cosine, and tangent are all positive. Remember, quadrant 1, all of them were positive, sine, cosine, and tangent. quadrant 2 cosine, which is x. X over here is negative, and y over here, which is sine, is positive, and then tangent ends up being negative because it's y over x. Down here in quadrant 3, both x and y are negatives, so sine and cosine are both negatives down here, but when I find tangent, I do a negative divided by a negative, which is a positive. And then over here in quadrant 4, over here x's are positive, so cosine, which is x, is positive down there over here. Y's are negative though, because it's below the x-axis, so sine is negative, and then tangent is negative because it's a negative divided by a positive. And again, you should have that on your unit circle, but I just want to remind you. Let's look at example A. I'm going to find my reference angle. So step 1, graph my 300 degree angle. So I know it's somewhere in between 0 or 270 and 360, I guess I should say. So here's my reference angle right here. And I need to ask myself, what is the distance from that to 360? It's a distance of 60 degrees. So here's what I'm going to do. I'm going to find the value of sine at 60 degrees, and then depending on the quadrant, I'm going to make it positive or negative. Now, just a quick review. I've said this a bunch up here, but x is positive and y is negative. And we've been working on this a little bit, but let's look at your unit circle. Quadrant 1 is a quadrant you're going to want to have memorized, because based off of this, I can find everything else in the unit circle. And I have just quadrant 1 of the unit circle, so it goes from 0 to 30, 45 degrees, 60 degrees, and 90 degrees. So 0, 30, 45, 60, and 90. In radians, that would be 0, pi over 6 radians, pi over 4 radians, pi over 3, pi over 2. And then here are my points. And here's how I always have this memorized. First of all, 90 degrees is at 0, 1, because it's my unit circle, and it's 0 along the x and 1 along the y. And so my point down here is 1, 0, because this time it's 1 along the x, 0 along the y. Now here's how I remember the rest. 45 degrees is always easy, because that is square roots of 2 over 2, square roots of 2 over 2. That's the one that's the same both times. And then when I think about my x values, remember what I said in class. It goes 0, 1, 2 on top, 3 on top. So just pause for a second and look at the x's. 0, 1, 2, 3. It's just the square root of 1 is 1, so that's why I write 1. I don't write square root of 1. Okay. And then, switching back to my regular pen, 3, 2, 1, going the other way. So in my mind, here's what I'm thinking. Sine is a y value. Where is my, sorry, I guess I should say at 60 degrees, what is the y value then? At 60 degrees, the y value is square root of 3 over 2. And so my first part of my answer is square roots of 3 over 2. That's me doing step 2 up here in the directions. But step 3 says use the quadrant where the angle is located to determine positive or negative. This angle is actually down in quadrant 4. And now, is sine supposed to be positive or negative in quadrant 4 is a question. Sine is supposed to be negative. So the final answer is negative square roots of 3 over 2. So I use my quadrant 1 in order to find the value, and then based off of the rules for the signs, then I find if it's positive or negative. Let's do another one. Step 1, graph it. And when I graph it, I end up with 315, so that's again down in this quadrant down here. And we are going to finish the rest of this in class. Thanks for listening.